What if you could run a fully functional web browser inside your Godot game, with GPU acceleration, smooth 120 FPS rendering, and full interactivity, not as an overlay, but as an actual texture that you can place on 3D objects, bend, twist, and interact with? This is Godot CEF, a high-performance Chromium integration for Godot Engine written in Rust. Game UI development is hard. Building complex, responsive, animated interfaces with game engine's built-in nodes can be time-consuming. Meanwhile, web developers have decades of tooling: HTML, CSS, JavaScript, React, Vue for creating beautiful interactive interfaces. What if you could use those web skills inside Godot? Previous solutions existed, but they had limitations. Software-only rendering would be too slow, OS native web views couldn't be embedded in 3D scenes, and cross-platform consistency was a nightmare. We built Godot CEF to solve exactly this problem. So Godot CEF is a high-performance Chromium Embedded Framework integration for Godot Engine 4.5 and above. It's written entirely in Rust using Godot Rust, giving you memory safety and modern tooling. At its core, it provides a single powerful node called CEF texture. This node renders any web content, HTML, CSS, JavaScript, WebGL, even WebGPU, directly as a Godot texture. It's that simple to use. You see, 4 lines of code, that's it. The headline feature is GPU accelerated off-screen rendering. On Windows, we supported DirectX 12, on macOS Metal, on Linux and Windows Vulkan. The web content renders directly on your GPU, achieving frame rates you might have never seen from embedded browsers. Because CEF texture renders to an actual Godot texture, you can use it anywhere: on a 2D canvas, on a 3D mesh, on a material on a curved surface, on a browser on a TV screen in your game. Done. A holographic UI in VR? Absolutely. Godot and JavaScript can talk to each other seamlessly, execute JavaScript from GDScript with Evo, and send messages back to Godot using our IPC system. The latency will be within 1 frame, perfect for building game UIs with web frameworks like Vue or React. This isn't some limited web view, it's Chromium, the same engine powering Google Chrome. Modern JavaScript, HTML5, CSS3, WebGL, WebGPU, it all works. We usually start a VidDev server and edit the UI interactively with hot reloading all the time. It's so convenient. We've also included Chrome DevTools support for remote debugging. Inspect elements, debug JavaScript, profile performance, all the tools you are used to. Let's talk about something that sounds simple but costs weeks of debugging: multi-GPU systems. Modern laptops often have 2 GPUs, an integrated Intel or AMD GPU for battery life and a discrete NVIDIA or AMD GPU for performance. When Godot and CEF need to share textures, they must be using the same GPU. There's no cross-GPU texture sharing. Without explicit coordination, Godot might pick the discrete GPU for performance, while CEF's subprocess defaults to its integrated GPU. The texture handles are valid, but only on the GPU that created them. Our solution? GPU device pinning. At startup, we query Godot's rendering device for the GPU vendor and device IDs. On Windows DirectX, that's DXGI adapter descriptions. On Vulkan, it's VK physical device properties. On macOS Metal, we dig into the IO kit registry. Then we pass these IDs as command line switches to every CEF subprocess. Chromium uses these to select the exact same GPU adapter. It's a simple solution, but discovering it required understanding the internal architecture of both Godot and Chromium's GPU process selection. For example, you must send the IDs to CEF in decimal format, while they were usually represented in a hex format. Now the part that keeps me at night: Vulkan extension injection. GPU accelerated texture sharing requires specific Vulkan extensions. On Windows, That's VKKHR external memory Win32. On Linux, it's VKKHR external memory FD and VKEXT external memory DMA buff. These extensions let one process export a texture handle that another process can import. Okay, here's the problem. Godot doesn't enable these extensions. When Godot creates its Vulkan device, it only requests the extensions it needs internally. There's no API for GD extensions to say, hey, I need these additional extensions. So what do you do when the engine doesn't give you an API? You make one yourself. We use runtime function hooking. Specifically, we hook vk_create_device, the Vulkan function that creates the logical device. Timing is critical. The hook must be installed before Godot creates its Vulkan device. We carefully read the source code of Godot and found that we can install it during the GD extension core initialization stage, the earliest possible moment. Is this hacky? Absolutely. Is it stable? Surprisingly, yes. Could antivirus software flag it? Possibly. But here's the thing, we're not satisfied with workarounds. We've submitted 2 upstream contributions to eliminate the need for these hacks entirely. So first, PR number 77 to Retour RS adds ARM64 support for function hooking. Second, and this is the big one, the PR number 114940 to Godot itself, it adds a proper API for GD extensions to request additional Vulkan extensions during device creation. Okay, once Godot merges this PR, the entire hook-based approach becomes unnecessary. GD extensions will be able to cleanly request VKKHR external memory and friends through an official API. Until then, the hooks work, but we are actively working to make them obsolete. Yeah, the best code is the code you can eventually delete. You might wonder, we added ARM64 support to Retour. Why doesn't Vulkan hooking work on macOS? The answer is there's nothing to hook. Godot statically links Molten VK, the Vulkan to Metal translation layer, directly into its binary. When Godot calls vk_create_device, it's not calling through a dynamic library's PLT or GOT tables. It's jumping directly to embedded code. There's no indirection point for us to intercept. Function hooking works by replacing entries in those indirection tables. No table, no hook. It's that simple. So we spent weeks on ARM64 support for Retour, and then realized it doesn't matter for macOS. The entry point just doesn't exist. But here's the silver lining. We don't need it. macOS has native Metal support, and Metal's IO surface sharing works beautifully. No hacks required. It's actually our cleanest implementation. This project wasn't built in a vacuum. It was created during the development of Engram. It is a CYOA game that needed a complex interactive UI. The initial version used the Godot WRY, which worked great for an overlay UI, but we needed something more. It's not working on Linux. Consistent cross-platform behavior is bad. About 50% of the users who crash on startup is because they are using old Windows versions without built-in Edge Web View. So we built Godot CEF, and we are open sourcing it for the entire Godot community. Let's be fair, Godot CEF isn't the only option. Godot WRY uses your OS native web view. It's lightweight and great for simple overlays, but the browser sits on top of your game. You can embed it in 3D things, and the behavior varies across platforms. GDCF is a C++ CEF integration with a longer history, but it's software rendering only, which limits performance. Godot CEF gives you the best of both worlds. GPU acceleration for performance, texture-based rendering for flexibility, and the same Chromium Engine everywhere for consistency. Getting started is easy. Head to Godot Access Store or our GitHub releases page, download the pre-built binaries for all platforms, and extract them into your project's add-ons folder. The full API documentation is available online, covering properties, methods, signals, and advanced features like drag and drop and IME support for international text input. If you want to build from source, we've got you covered. This project uses Rust nightly, and our Xtask build system handles all the complexity of bundling CEF binaries. Godot CEF is open source under the MIT license. If this project is useful to you, consider giving us a star on GitHub. It helps others discover the project. We welcome contributions, whether it's a bug report or feature requests or pull requests. Check out our contributing guide to get involved. And if you want to help make Godot better for everyone, not just Godot CEF users, consider leaving a supportive comment on our Godot PR number 114940. Community support helps PRs get reviewed and merged faster. If you build something cool with Godot CEF, we'd love to see it. So tag us, share your creations, and let's push the boundaries of what's possible in Godot. And thanks for watching.